All right, here's some homework help for the rational expressions section. First question says find the domain. Whenever they say find the domain, they're wanting to know what allowable x's there are. And there's only a couple that we worry about of times when you can't allow a specific x. And the two I'm thinking about are having a 0 on the bottom. So say I have like x minus 2 here. I can't have a 0, whatever this is on the numerator. I can't have a 0 be on the denominator. So in this case here, x could not be equal to 2 because 2 minus 2 is 0, so you can't have that. Another time where you can't have an x value or a different kind of x value is if you have the square root of something. So if x were a negative number, like -1, under the real numbers, we don't allow that. And so we can allow it under complex numbers, but typically we're dealing with real numbers, so you can't have that. Anyway, so if they ask for the domain, they're really saying what numbers are allowed to be in for x. On the top here, you can plug any number in there you want. Doesn't matter. But on the bottom, you can't plug a number in there or there that would make the resultant expression equal to 0. So I would do something like this. I would say, well, whatever x times x minus 4 is, that cannot equal 0. And this is a 0 property that we've seen in other videos where something times something can't be equal to 0. So I would say, well, either x can't be equal to 0 or x minus 4 can't be equal to 0. Solving this equation with an unequal sign there, not equal sign, I'm going to add 4 to both sides. So I'm going to say in this case here, the domain is any real number, any number you want to plug in there, as long as x is not equal to 0 or 4. Okay, so that's the domain. Okay, now we have to simplify some expressions here. If they want to simplify, even if they say multiply or add or subtract, often what you're doing with these expressions is factoring. So I'm going to factor this expression. The top, I believe, is z minus 4 times z minus 4. You can check that. On the bottom, that's a difference of squares. So I have a z and a 4, a z and a 4, one's minus, one's plus. Now, this and this are the same factor, so that's a factor of 1. That gets eliminated. So my answer to this question would be z minus 4 over z plus 4. Next question, looks like I can factor a 3 out. And so I'd be left with r squared plus 8r plus 15. On the bottom, I could factor, I bet I can factor a 9 out, leaving me with r squared minus 2r minus 119, I think. Is that 135 divide 9? Let me check that. 1, 5, not 19, 15. So 15. Okay, now I believe I can factor that top thing. Two things that multiply to 15 and add to 8, I'm thinking are 3 and 5. On the bottom, I have 9. I'm just going to rewrite that 9 as 3 times 3. And then I'll bet I can factor this. I think it'll be r minus 5, r plus 3. You can check that. And now to take out factors of 1, I can get rid of these 3's right there. And then there's an r plus 3 here and an r plus 3 there on the top. So on the top, I'd be left with r plus 5. Notice I got rid of the brackets because it's the only thing on the top. On the bottom, I have a 3 and I have an r minus 5. Okay, and that would be the answer to that question, or the simplification of it. Next question, we're dividing. Okay, dividing means factor and then cancel stuff. So I'm going to factor this. I think that's a difference of squares. So n minus m and n plus m over w minus z, can't factor that. Divide, I'm going to change that divide to times, and I'm going to flip these two things over. So the w minus z will go on the top, and the n plus m go on the bottom. Now look to cancel stuff. So here's a factor of 1. Notice you always have to take one on the top, one on the bottom. Here's another one that's the same. So my answer will just be n minus m. Next question, same kind of thing. I'm going to factor as we go. This first one we've seen already. A plus 3, a plus 5. The bottom, a minus 5, I think, and a plus 4. Is that right? Yeah, that's right. Okay, change the divide to a times. And then I'm going to factor that. That looks like I can just take out a common factor of a. I'll be left with a plus 5. And on the bottom, another factor of a, and it'll be a minus 5. Uh-oh, I didn't flip them over. Whoops. Okay, so if I flip them over, it's basically the same thing, but the minus should have been on the top, and the plus should have been on the bottom. Okay, now look for factors of 1 that I can eliminate. So a plus 5, a plus 5. A minus 5 on the top, a minus 5 on the bottom. Oh, and just a plain a by itself, a, cancel. Notice I couldn't cancel this a and this a because they're bound with that plus sign. So I can't just cancel them. So that's what I'll be left with in this question. I'll have an a plus 3 on the top and an a plus 4 on the bottom. Okay, multiplying, same thing. So I'm going to factor first, then see if I can cancel. So I have y minus w, y plus w over, difference of cubes. So y minus w, and then y squared plus yw plus w squared. You might have to check your formula to make sure that's correct. I think it's correct. Times on the top y squared plus yw plus w squared over, I think I can factor that one. I think it's y plus w, y plus w. Again, notice that it's factor, 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 factor. A ton of that. So you want to make sure you're comfortable with them. Okay, factors of 1 that I can eliminate. There's a y plus w, y plus w. There's that whole thing is the same on top and the bottom. Y minus w, y minus w. I think that's it. So on the top, I don't have anything, so we'll say it's a 1. And on the bottom, I just have y plus w. Factor, factor, factor. Next question. Okay, now we're adding. So if I'm ever adding expressions, I have to have a common denominator. First step of doing that is to factor the bottom. So I'm going to factor this. Probably a 5x here and an x there. Okay, I have to multiply to 36 and 5 maybe. 6, maybe a 5 here and a 6 there. And the bigger thing has to be negative. So this would be negative, this would be positive. 5x squared. Okay, 5x squared minus 25 plus 6, yeah, it's minus 19. And minus 30, yeah, that's right. Plus x plus 9 over, let's factor a 5 out, left with an x minus 5. Okay, in order to combine those or to add them, I need a common denominator. So I think my lowest common denominator must include both of these. So a 5x plus 6 and an x minus 5. I don't have just a plain 5 yet, so I need one of those. I'll put it up front here. And an x minus, I already have that. So this is my lowest common denominator. So this one here I'm going to change so it has that. So I have x squared minus 2 over 5x plus 6, x minus 5. That's what I have. plus, over here I have x plus 9 over 5, x minus 5. That's what's originally there. But my common denominator for this first one, I don't have a 5, so I need to put a 5 in there. But if I put a 5 there, I also need to put a 5 up top. Okay, for the second one, it looks like I don't have this. And so I need to include a 5x plus 6 on the bottom. If I do that on the bottom, I'll also need to include one on the top. Now that they both have the same denominator, now I can combine them. So let's put one denominator, a 5x plus 6, x minus 5. That's our common denominator. Then on the top here, I'm going to multiply this out. So it'll be 5x squared minus 10. And I'm also going to FOIL this out. So plus 5x squared plus 6x plus 45x plus 54. Now just collecting like terms, 5x and 5x squared would be a 10x squared. The x's, it looks like I'll have 51x. And then the numbers, it looks like I'll have a positive 44. All over my lowest common denominator. So that would be my answer to that one. That's one of the harder questions. Finding common denominator is tough. If that would have been a minus, that might have been a little bit harder because that minus in the middle there would affect all the terms coming after it. That's a fairly tough one. Oh, here's a minus one. Speaking about tough ones. Okay, let's start it then. So first thing, factor the bottom. Looks like it'll be y minus 6, y plus 1, or w minus 6, w plus 1. Does that work out? Yep. Minus 7 and w plus 1. So my lowest common denominator is going to be, I need w minus 6, w plus 1, and then, well, I already have that one. So just this will be my lowest common denominator. So let's write what we have. W over w minus 6, w plus 1, minus 7, and w plus 1. And then to get my common denominator, this one is already common. I don't need to change anything. But this one, I need to include a w minus 6 on the bottom. If I do it on the bottom, I also need to include it up top. Now I've got a common denominator. So I can write it down here, w minus 6 and w plus 1. And then up top here, I'll write what I have, a w. And then this minus goes with the 7. Maybe I'm just going to write it as what I have up there. And hopefully that'll let you see that I'm going to have to take this minus 7 and multiply by both things inside there. Not just a 7, but a minus 7. So on the top I'll have w minus 7w plus 42 over my lowest common denominator. And then on the top, w minus 7w would be a minus 6w plus 42 over w minus 6, w plus 1. You could probably leave it there. 6 will divide into both 6 and 42, so you could rewrite it as minus 6 w minus 7 all over the lowest common denominator. But if I can't cancel anything after that, and I can't cancel those minus 6's because this one's anchored with the w. So if I can't cancel anything, I might have just left it at that point there. Okay, here's some two complex rational expressions. And the key with this is just to recognize that that middle line means divide. Actually, all the lines mean divide, but the middle one being divide helps you write it out. So what I would do is I'd write it out as b squared minus c squared over bc divide b minus c over c. Now, this is a dividing fraction, so change the divide to multiply and invert the second fraction. b squared minus c squared, I'm just going to factor that because I see that that's a difference of squares, over bc. Now this changes to a times, and the c will go on the top, and the b minus c goes on the bottom. Now I'm going to look for factors of 1 that I can remove. There's a b minus c, a b minus c. Something divided by itself is 1. I can remove those. This c here cancels with that c. I'd love to cancel this b with this b, but because the b is anchored with the c, I can't. So my final answer here, on the top I'll have a b plus c, on the bottom a b. Last question, a similar one. Okay, so I'm just going to try and do a couple steps in my head here. This first one's a difference of squares again. So it's 4x minus 3y times 4x plus 3y over xy. And then remember, this line means divide. So over on this side, I'm going to change it to a times, and I'm going to flip it over. Y over 4x plus 3y. Now look for factors of 1 that you can remove. And here's a 4x plus 3y, there's a 4x plus 3y. Here's a y, there's a y. So my final answer will be 4x minus 3y over x. Love to be able to cancel this x and this x, but I can't because it's anchored with that minus sign. So that would be my final answer. Hopefully that helps you with the homework on that section.